This is Barry Zalma on insurance. When considering construction defects and insurance claims, it is essential that the claims person and the lawyer understand basic construction. To understand the construction defect claim and the litigation surrounding construction defects, it is essential to have a basic understanding of construction, what is proper and prudent, and what can go wrong. Building codes prescribe basic standards. When these standards are not followed, or are not followed carefully enough, a building can fail. It may leak, or lean, or even fall down, as happened in Florida just this year. Let's discuss a brief overview of the component parts of a standard dwelling built of wood framing using common construction methods used over the last century, and the problems that can arise when any part of the building fails. To make things simple, we'll discuss the single-family dwelling. Multifamily and commercial buildings are larger, have more parts, and are much more complex to construct. Newer building materials and techniques are not discussed, nor will we discuss factory-built homes. Note that modern buildings may use steel in place of lumber in the framing, artificial rather than cement-based stucco, computer controls for electrical appliances and heating, ventilating, and air conditioning systems, and other modern materials and construction techniques. Regardless of the materials and techniques used in construction, the points at which the structure may fail are essentially the same. Typical single-family homes built during the last century were constructed with a wood frame built on top of a concrete foundation. The foundations are either raised on piers or poured flat on grade. The lumber that makes up the wood frame is usually jacketed with lath, thin wood strips, or a moisture barrier paper with a wire covering that is covered with stucco, a durable, porous concrete product. Exterior insulation and finish systems, artificial stucco, or wood or vinyl siding. The interior walls are usually finished with drywall, that's gypsum covered in paper that when finished gives the appearance of lath and plaster, or in older structures, wood, lath, and plaster. Basic single-family dwellings are usually 1 to 2 stories in height and range from 900 to 3,500 square feet. Of course, there are mansions where a single family may reside in a 20,000 square foot structure. It is becoming common to remodel old dwellings of 900 to 1,100 square feet into 5,000 to 7,000 square foot McMansions, or on small residential lots. These extreme remodeling efforts often run afoul of claims of construction defects. The component parts of single-family dwellings start with the footings. Concrete footings are the base for the foundations upon which the dwelling is built. They are poured in forms using a 1-2-4 mix of concrete and reinforced steel of various sizes. Failure of footings can cause the dwelling to sink, slip, or lean, causing plaster walls and stucco to crack, roofs, windows, and doors to lose their watertight seals, and doors to creak. Spread footings are constructed with a wide base that helps create a large area to transfer the weight of the structure to the ground and prevent the structure from sinking. The thickness of the footing provides the footing with the strength needed to support the weight of the structure. In modern construction, a footing is usually 16 to 24 inches wide and 6 to 16 inches thick, and made with poured concrete that is rated to withstand 2,000 to 5,000 pounds per square inch of compression pressure. The dimensions of the footing may vary according to the soil conditions under the structure, the weight or load placed on the footing, and construction style of the home. A continuous spread or strip footing can be found around the perimeter of the structure. It supports the weight from the exterior or foundation walls. In areas subject to seasonal frost, a footing must be placed below the frost line to prevent frost heaving that may lift and damage the footing and structure. A pad footing is like spread footing, but it is usually used to support a single point of contact, such as under a pier or a post. The pad footing is usually 2 foot by 2 foot square pad, 10 to 12 inches thick, and is made with poured concrete that is rated to withstand 3,000 to 5,000 pounds per square inch of compression pressure. For typical soils, a common 16 or 20-inch wide footing can more than handle the relatively light weight of an ordinary house. Of course, consideration must be given to the type of soils on which the footing is installed. For example, when built on soft clay soil, or if there's a soft zone under part of the foundation, there can be trouble. A footing that performs well in good soil may not do so well in weak bearing conditions. If the soil is soft, it is not uncommon to see excessive settlement where the bearing capacity of the soil is low. If there is a soft spot in the soil, widening the footing may be the simplest solution to avoid differential settlement. Increasing a 16-inch footing to 32 inches doubles the bearing area, making the footing suitable for soil with half the capacity. Of course, failure of a footing means failure of the entire structure. In addition to footings, foundations can be created using piles of wood, concrete, or sometimes metal columns that are driven into the ground and used to support the structure and prevent it from sinking. Piles are either driven down until they hit bedrock, or if bedrock is too difficult to reach, the piles are driven to a depth where the soil friction against the side of the pile is sufficient to prevent any further downward movement. The piles are connected using a continuous grade beam across the top of the piles, forming a base upon which the structure is then placed. Piles are used in areas where footings are not feasible or desirable, such as with poor soil quality or a high water table near an ocean or riverside. Masonry foundations are constructed from concrete blocks embedded in 3/8-inch mortar joints with reinforcing steel, 9-gauge by 9-gauge for 8-inch and 12-inch thick walls. Complete failure of a masonry foundation can result in the collapse of the structure, while partial failure can cause cracking of walls and failure of watertight seals. Cast-in-place concrete construction involves setting up removable forms for the pouring of concrete foundation walls. It is a common method for all types of foundations, basement, slab-on-grade, and crawl space. After the footings and foundations are created, basic frame construction begins. And basic frame construction consists of a standard wall created 8 to 12 feet high. Boards used are approximately 2 inches by 6 inches and are commonplace in residential construction because they provide a wider cavity that accommodates more insulation than the standard approximately 2 inch by 4 inch boards. The 2x4 is still the most popular for remodeling and add-ons. Framing consists of top and bottom plates, wall studs, headers, and trimmers king studs as needed for window and door openings. In current practice, wall studs are generally spaced 16 inches apart on center. Most plans call for 2 top plate layers. The second or cap plate fits on the top plate. Most plans include a door and window openings in the wall. Additional framing support is needed to transfer the structural weight over the opening of the door or window and down to the floor. Exterior sheathing, either 4x8 or 4x9 oriented strand board or plywood sheets, is nailed to the framed wall. The sheathing adds structural integrity to the building and eliminates the shearing of the exterior coatings. The sheathing is often referred to as shear walls. Most interior details, mainly walls and closets, are built with 2x4s. 2x6s take up more space. Interior walls usually do not bear any loads of the structural elements. Virtually all roofs on new homes are built with prefabricated trusses, which go up much faster than hand-framed roofs. Even small additions use a few trusses rather than frame the roofs by hand. Roof trusses are generally made to order for a given construction or remodeling job, and they usually require about 2 to 3 weeks of lead time before they can be delivered and installed. Failure in framing can cause plaster wall finishes to crack, windows and doors to tilt and lose their watertight seal, and it can also cause walls to be out of plumb. Serious defects in framing, like improperly attaching the foundation wall, can cause the structure to collapse or be in imminent danger of collapse. The framing described is common wood construction and is not necessarily what is used in every construction. Construction may also include steel framing, mud bricks, straw construction, and construction methods more environmentally friendly than frame and stucco construction. Exterior wall finishes can include things like Tyvek brand house wrap or its equivalent, which is used below the exterior finish as an air barrier or weather barrier. Building paper, felt, or its equivalent is usually used for masonry applications with wire lath. Stucco wrap will use a Tyvek-type material with ridges for air ventilation. Exterior wall finishes are placed over the wood frame. Stucco requires a base of 18-gauge wire, 15-pound felt paper, and 1-inch by 18-gauge galvanized netting upon which is installed mortar with a 1:3 ratio. A cubic yard of mortar is usually made up of 1 cubic yard of sand, 9 cubic feet of Portland cement, and 100 pounds of hydrated lime. When the builder attempts to save money by creating mortar with less than the proportions necessary for proper mortar, it can fail to hold to the wall or lose its shear strength. When wood siding is used, it can be made up of the following: bevel siding, drop siding, vertical siding, batten siding, plywood siding with battens, or wood shingle siding. Each type of siding is manufactured in different sizes and shapes to assist the builder. Some examples include aluminum siding, which is both durable and virtually maintenance-free. This siding can be installed over most existing sidings or rigid foam insulation. Brick finish can come in different colors, shapes, and textures. It can be used for interior and exterior walls, fireplaces, and around ovens and cook ranges. concrete block is made from a mixture of sand, gravel, pebbles, stones, and cement. Concrete block comes in different finishes and can be very aesthetically pleasing. EIFS, Exterior Insulation and Finish Systems, is a thin synthetic system with a finish like stucco. EIFS is applied to insulation board that is applied to sheathing or siding mounted to wall studs. This product is inexpensive, durable, and has a wide range of colors. It is used on many buildings in the U.S. Correct installation is essential because improperly installed EIFS have been the root cause of many lawsuits, as they allow water infiltration to the structure, a condition which encourages mold to grow between the walls. Lap siding can be wood or vinyl. Each piece is tapered with a notch on it, and it will need to be painted every 5 to 10 years and can split and or warp. Stone finish can come in a variety of colors, shapes, and sizes. Natural granite, marble, river rock, limestone, stream stone, ledge stone, field stone, and quarried stones are only a few types of rocks that can be purchased. Vinyl siding in today's market is more prevalent than aluminum siding. Vinyl is durable, flexible, and virtually maintenance-free. Defective installation of exterior wall surfaces can cause the building to lose its watertight nature. Defective installation of exterior wall surfaces can also allow the interior wood surfaces and the paper covering on sheetrock interior wall coverings to become wet and encourage the growth of fungi, mold, and bacteria that can be dangerous to the structure and to its occupants. This video was adapted from my book, Construction Defects and Insurance, Volume 1, which is one of an 8-volume treatise on construction defects and insurance. It is available as both a Kindle book and a paperback from Amazon.com. If you found this video to be interesting or useful to you and your colleagues, please pass it on. It's free. And please also subscribe to my Rumble channel, my YouTube channel, and my blog and Substack publications. Thank you for your attention.